This is a Hewlett-Packard 8640B signal generator that I've been working on, and I just thought I'd do a little demo of how the FM deviation switch works and how this unit compensates for changing the range while maintaining the same peak deviation. And the reason that this is necessary is because the master oscillator, which is a tuned cavity, which runs from 256 to 512 megahertz roughly, is divided down into different frequency ranges by a series of chips, flip-flop chips, that eventually get it down to the lowest range, which is 500 kilohertz to 1 megahertz. But every time you divide that frequency range down, any FM modulation which is applied to this oscillator, and it's applied in here with a varactor diode, is also divided down. So, you know, what might be 100 kilohertz deviation in one setting will become 50 kilohertz deviation when it's divided down, and so on. So this could have been done electronically, and it would be at a later date. This was an early 1970s design, and I'm sure a microprocessor could deal with that very easily. But what HP decided to do was to take a simpler route and use a differential gear mechanism in the switching arrangement. And in here I've replaced some of the gears with brass gears because the original Delrin gears had split, which is very normal for these signal generators after several decades. This unit's 47 years old. So what happens is when you change the peak deviation switch, the first rotor controls the meter and the meter scale lights. That's all that one does. And then the shaft then drives this gear, this spur gear, which drives two more spur gears, just idler gears, onto the differential mechanism. And what the differential mechanism does, it allows this knob, the peak deviation knob, and the range switch to both control the rear switch wafer, which is there's a 4-wiper switch wafer back there. And that controls the gain of the FM modulation amplifier, which is this circuit board here. And there's a little table in the manual that kind of explains how much gain is necessary for each combination of peak deviation and which range it's set to. So for example, at the moment this is set, sorry it's upside down, but I need it upside down to view the gears. This is set for the 256 to 512 megahertz range and a peak deviation of 640 kilohertz. That can be adjusted with this vernier on the control, but the maximum that can be set on that particular range is 640 kilohertz. Now, I don't know if you can see this, but the switch wipers, so it's a printed circuit board switch with 4 wipers on it, and it's in that position there at the moment. If I change the range to the next lowest range of 128 to 256 megahertz, what that did was it moved the switch from there to there. Now that will have changed the peak deviation because it's divided down by a factor of 2. So that's what that switch wafer did there, was actually reduce or change the value of the amplification of the FM amplifier board. Now, if you then change the peak deviation, you can see that changed the position of the differential gear there, and it moved the switch rotor back to the original position, which adjusts the gain of the FM amplifier again, it's quite a cunning mechanism. It just, every time it does a switch position on that rotor there, it either adds 6 decibels, dBV that is, or reduces by 6 dBV to increase or reduce the amount of voltage applied to the varactor diode in the cavity there, to compensate for the division of the frequency. Simple as that. But it's kind of, it looks overly complicated, but it's actually quite a simple mechanism. But it is a These gears are a bit of a Achilles heel in this signal generator, as are the wipers on these switches. And I had to replace one wiper that had dropped off and lost. I also glued all the wipers down to the rotors with some epoxy to stop it happening again. And a similar switch is actually on the back of the attenuator unit there. I haven't done anything with that one yet. It seems to be working okay, and I'll deal with that if I need to in the future. There we go. HP8640B signal generator.